Okay, let's take a look at our second example. We have f of x equals e to the x over x squared. We're going to evaluate the limit as x approaches infinity of f of x. Now, just to let you know, L'Hopital's rule also works for x approaching infinite values, not just finite values. So this will work just like the last example. We're going to follow the same steps. So we're going to identify the indeterminate form by plugging in this approaching x value. In this case, we'll be plugging in infinity. If you're confused about plugging in numbers for limits, go back and look at that lesson for evaluating limits by plugging in. Also, you might want to look at the lesson for evaluating infinite limits. But anyways, e to the infinity is going to be infinity, right? It's e to a really, really big number, and that's going to make it even bigger. Also, infinity squared is going to give you infinity back. So this just simplifies to infinity over infinity. And like we talked about before, if you get one of these four indeterminate forms, you know you're going to use L'Hopital's rule. So here we go. In order to do that, we're going to take the derivative of the top and bottom, okay, just like we talked about before. Derivative of e to the x is the only function I know whose derivative is itself, so it's also e to the x, and d dx of x squared is 2x. So now that we've taken the derivative of the top and bottom, what we're going to do now is simplify that, and this is as simple as it can be, so we're going to move on. Then we're going to plug in the limit. So then we're going to plug in infinity. E to the infinity is infinity, but guess what? 2 times infinity is still infinity also. So we got an x here because it's still an indeterminate form. And again, as long as it's in one of those indeterminate forms we talked about, we have to keep taking the derivative until it works out. So this leads us to the first time we're going to be applying this step. And this step is we still ended up with an indeterminate form. We were going to persist in applying L'Hopital's rule again by finding its derivative, then try to evaluate again. Okay, so here we go. Derive again and evaluate again if it's indeterminate. So it's still indeterminate. We got infinity over infinity, so we're going to derive our new function. E to the x is still e to the x derivative, but now we can take the derivative of 2x and we get 2. So we get e to the x over 2. Now that we've taken the derivative again, then we can go ahead and try to plug infinity again and see what happens. And some of you can already see you're not going to get an indeterminate form back. Why? Because we can plug in infinity at the top. It's still going to be infinity like before. However, for the bottom, if you plug in infinity, there's nothing to plug in, right? It's still going to be 2. There's no x value to plug in. So you get 2 on the bottom. And we know that infinity over 2, don't need a Java update right now, infinity over 2 is infinity. So, now why is that? I mean, some of you might be confused because if it's infinitely big and you cut it in half, it's still going to be infinitely big. It's kind of hard to explain. But yeah, just imagine taking like a trillion and dividing it by half, okay? Well, you think that's finite, right? But what if you doubled a trillion and then half that? Then it'd be a trillion again. But so infinity is as big as you can possibly be. If you cut it in half, it's still infinity. Very abstract concept. I want to thank website Paul's Online Notes for these examples. I do have one more example I'm going to go over. But this is a great website to check out. Reference it a lot. He's a professor, I believe. And just use kind of his examples as inspiration for making these and kind of breaking it down with step by step. Okay? So great website to check out if you get a chance. Next we'll take a look at example 3. Oh, actually before that I did want to show you a graph of this function. I almost forgot. And so we found the limit of this function to be infinity. So basically as x approaches infinity, y approaches infinity. Let's take a look and see what that would look like on a graph. Okay, so I'm using Desmos as usual. Again, a great app to use for graphing. And as you can see, in fact, it's going to be hard for me to notate this. Give me a second. Okay. As you can see, as x approaches infinity, and by the way, what graph is this? This is e to the x over x squared, our original function. As x approaches infinity, y approaches infinity, which is what we found the limit to be. Just confirming that L'Hopital's rule works. It's a visual confirmation. Again, for the next example, we will use L'Hopital's rule, and I'll try to show you a graph of that as well.